Alright, so another IB surface area examples. So a silo has a cylindrical part in the roof that is a hemisphere, so it's half a sphere. The radius of the cylinder is 3 meters and its height is 12 meters. A, find the volume of the silo, and B, it's asking us about surface area. So a few of the equations that we should remember that we will have to use in this case. So the first one is the volume of a sphere, which is 4/3 pi r to the power of 3. Also, the surface area of a sphere. So that's 4 pi r squared. Alright? What else? Well, the cylinder, we may just calculate using a circle and extruding it through a height h, right? If this is height h and radius r, we would have this to be h pi r squared. That's the volume of the silo and the surface of the cylinder. And for the surface area of the cylinder, in this case, since it's not going to be the full cylinder, because the question is asking us, okay, we're gonna paint on the surface, so the only surface that we'll have here is this rectangle, right? If you could cut it here, right, and open it up, right? If this is your cylinder here, so if you cut it through here, right, you would then get just a simple rectangle. Now this length would be this length, right, which is the circumference of this circle. So this would be 2 pi r. And this height is the height of the silo. It's the height of the cylinder. So this is the actual area that would have to be painted, considering, and well, if we analyze those equations, we will also have to modify them because they are for the full sphere. But here I'll just put the surface area that is going to be meaningful to us. So 2 pi r h. Right, now if we adapt those equations for our case, since it's a hemisphere, it's going to be half the volume and also half the surface area. So this will now be 2. Alright, now find the volume of the silo. So the total volume will be simply the sum of those two volumes. It's the volume of a hemisphere and the volume of the whole cylinder. So it's 4/6. We can simplify this, right? We can get 2/3. 2/3 pi, and now we're given r. R is 3 meters. So 3 to the power 3 plus the volume of the cylinder. So the height is 12 meters. I'm omitting here the units, but since everything is in meters, our result will be meters. So 12 times pi times the radius squared. So 2/3, let me get my calculator. So 2/3 pi times 3 to the power 3. We can even cross one of those 3's here out, right? This is a square, and we can get rid of that. So 3 squared plus 12 pi times 9. So we get 126 pi. Right? That's our total volume. You can leave it in terms of pi. This would be cubic meters, since everything is in meters. Now letter B. The entire silo is to be painted. find how much paint is needed if 1 liter of paint covers 8.5 square meters of surface. Well, so first we have to find what's our total surface area. So we'll have to add those two surface areas that we have found for the hemisphere and for the cylinder, for the outside part of the cylinder, which is just this rectangle. So the surface area will be 2 pi r squared, so 3 squared, plus 2 pi r, which is 3, and h, which is 12. So again here, that's 3 squared is 9, times 2 is 18 pi, plus 3 times 12, 36, times 2, 72 pi. So this would be 90 pi meters squared meters. Now, for this question, right, well, at least for this item, it doesn't really much make a lot of sense to have things in terms of pi, since we'll have to convert this to number and find a ratio. So if we convert this, so if we multiply this by pi, we would get this to be approximately 282.7 squared meters. I'm keeping many significant figures here. You didn't have to keep that many because you only have 2 significant figures here, but I've just decided to keep the same number of decimal places. So what we have to find here now is the ratio. So if it takes me 1 liter to paint 8.5 squared meters, how much would it take me to paint 282.7 squared meters? So that's our question. So we can just take an unknown here, a variable, and then we solve this for x. So x would be 282.7 divided by 8.5. So it's basically how many times can I fit 8.5 into 282. So if you work that out, you should find this to be approximately 33.3. It's not recurring, it's actually 33.2639, but I've rounded to 3 significant figures here. So 33.3 liters, right? However, if we were to assume that we can only buy cans of 1 liter, we would need 34 liters, right? If this is a problem that's only considering integer numbers, like how many paints of can, right? How many cans of paint would you have to buy? So your answer would have to be 34.